So the problem we're looking at today is the range sum query. It's a LeetCode easy problem, and we will be using Java for our solution. Now, the way to approach this is, if we look at the problem that's been given to us, we are given an array. What they want us to do is, given a range, we must find the sum of all the elements in that range. So for 0 to 2, that would be -2 plus 0 plus 3, which gives us 1. And similarly for 2 to 5, that would give us 3 plus -5 plus 2, which will give us -1. Now what we could do is go through all the elements in that given range and add them and get our solution. But every time we do that, we would have to go through the entire array for every range, and that would give us a time complexity of O of n squared. There's a simpler way, however, to do this. If you notice, every time that we try to find the sum in a given range, we add elements in an order. So if it's from 0 to 2, we add this to this and to this, which gives us 1. Or if it's from 2 to 5, we add elements from this to this to this to this. So this is basically like a cumulative addition, and we can use that to our advantage. There's something known as a prefix sum. It's basically an array wherein each element is a cumulative sum of the original elements of our array. So if we bring our original array again, which was, our new array becomes, for now I'm not filling in the index above, but it would be -2 plus 0 gives us -2 again, plus 3 gives us -1, plus -5 gives us -4, and then plus 2 gives us -2, plus of -1 gives us -3. So what this does is, it tells us that at each position, what is the sum of the numbers before it. So at this particular index, which corresponds to this, what is the sum from 0 to 2? It's -2 plus 0 plus 3, which is -1. And that's what we have here. But what happens if our left pointer is not at 0 or is not in the beginning? But we will notice here that if we take this, for example, which corresponds to 3 to 5, we have -5 plus 2 minus 1, which gives us -4. Now that we have -4, how do we get that here? Because we have a chunk missing from this area, and that's what we need to do. What we do is take our rightmost index, and from it we subtract the one just before the left index of the range that we're given. Why is that? That is because the number just before your leftmost element of the range is actually the sum of all the numbers before it. And that's what we want to do. We want this range out of this bigger range, and we want to remove these numbers, or rather these numbers. And in order to do that, we're already been given this number, which is a sum of these numbers. Now, all of this is very messy. What's a better way to do it? This is the method to do it, but a better and easier way to see it is if we just add a 0 in the beginning. Why is that? Because whenever we do this, if our leftmost pointer is 0, then we can't do left minus 1. And adding a 0 in the beginning of the prefix sum takes care of that issue. So the reason that I had not included the indices in the prefix sum array is so that I can show it to you now. And our prefix sum array becomes, you will notice now that for all corresponding elements of the original array, all the sums, or the cumulative sum rather, have shifted by one element to the right because we added a 0 in the beginning. Okay. So now we get to the Java implementation of this code. What we need to do here first is, in this method, we create our new array, the prefix sum array, and what we do here is return the sum for the given range. So the first thing we do is, so since we need to use our new array in both the methods, it's wiser to declare it first at a class level so that it's accessible in both the methods. Our new array prefix sum, and that's it. Now we want an array. Now, like we saw earlier, the new array is one element bigger than the given array. So we will initialize it to some array to a length of n plus 1, where n is length of nums. So let's quickly get the length of nums. Prefix sum is new n plus 1. Another thing about our prefix sum array was that our first element is always 0. So what we will do is prefix sum 0th element becomes 0. And now we fill in the new array, which is standard. For int I equals to 0, I is less than the length of the nums array, I plus plus. We iterate through each element, and then prefix I plus 1, because our 0th element is already 0, so we start from the next, is prefix sum 0 plus nums, sorry, it's not 0, it's I, which is the current element, nums as I as well, because it's cumulative in nature. And now we just return the sum. So what we do is, if our left pointer is at the 0th index, we simply return the value of the right pointer, or rather right plus 1, because we had shifted all our elements in the new prefix sum array to the right. So this becomes prefix sum, and else return prefix sum right plus 1 minus prefix sum left. Now earlier you might remember when we were looking at the problem, I showed that the final sum would be prefix sum right minus prefix sum left minus 1, but because we shifted the indices to the right by 1, that has been, the right shifts to 1 and the left minus 1 becomes left. Let's check if our code is running. Okay, left, oh, my bad. And voila, we have the desired output. Let's submit and check how we've done. Okay, all right. So this was the range sum query immutable problem in LeetCode, and it's an easy problem. The main solution here is prefix sum. Bye.